Hello Geometry, Mr. Fugay here, and for our video today we are going to take the converse of the Pythagorean theorem, which you've had now a chance to learn, study, and practice, and we are going to extend it and connect it to some prior topics we've already talked about in the course. So I have two extensions in this video that we're going to discuss. So for the first extension, we are going to go back to talking about the triangle inequality theorem. And just to remind you of what that is, the triangle inequality theorem says that in order to have three lengths of a side make a triangle, the two shortest sides must always add up and be larger than the third side. In my class, we had done an activity with straws or with a bunch of different lengths of things to see if some would be triangles and some wouldn't be. So here's a problem where we're going to connect that with the Pythagorean converse. So the question says, determine if the three lengths can form a triangle. So that first prompt right there, my highlighter will work here. This is using that triangle inequality. So we have to test that first. Once we've decided that it can form a triangle, then we will apply the Pythagorean theorem converse and classify the angles. So let's talk about the first part, all right? So what we need to look at is with the square roots, it might be helpful to find the decimal approximation in your calculator. See me if you're not sure how to do that, but the square root of 13 is about 3.6. So what I'm going to do for my triangle inequality theorem is realize that 7 is my longest side. So what needs to happen is that the square root of 13 plus 6 needs to be greater than 7. Well, when I put the square root of 13 plus 6 in my calculator and I get the decimal answer, I get 9.6 is greater than 7. Oops, got ahead of myself. I wanted to write the check mark. I was so excited. Check. So yes, this is a triangle. So now that we have that taken care of, now it's time to use the Pythagorean theorem converse. And this is the reason why I wanted to show this, because there's a difference. When you just simply add the two sides, it must be larger than the third side to use the triangle inequality theorem. But for the Pythagorean theorem converse, what I'm going to do is take the two shortest sides and I'm going to square each of them. Now I'm going to put a question mark here because I don't know what the inequality or equality sign will be, and 7 squared. So root 13 squared is 13, 6 squared is 36, 7 squared is 49. Again, we still don't know what that quantity is yet, but 13 plus 36 is going to be 49 and 49. And since those are equal to each other, the Pythagorean theorem converse says that this is going to be a right triangle. Okay? That's it. So you try the triangle inequality theorem first, see if it's a triangle. If it is, you proceed to use the Pythagorean converse. So let's try that on the second example over here. So first things first, let's try to figure out which of these is the shortest side. So if I put 5 root 6 in my calculator, the decimal approximation looks like it's going to be 12.24. So in order to try this, we're going to take 5 root 6, we're going to add it with 7, and it must be larger than 20 for this to be a triangle. When I add the two left sides together, I get 19.24. And as you can see, 19.24, is not greater than 20. So this is going to fail, which means that this is not a triangle. Now, the reason why this is so important to try this, if I can call triangle right, is that if you were to just jump into the Pythagorean theorem converse, you would still get an answer of acute or obtuse or right, but that answer is invalid because you can't even make a triangle with these side lengths. So that's why it's important to maybe always check that if it's a triangle first, then proceed to figure out what it's going to be. All right. At the end of the video, there are two examples, practice problems for you to try this first extension. Let's talk about the second extension. So the second extension goes to our coordinate geometry unit where we talked about classifying triangles on the coordinate plane. So when we first learned how to do this, if you were given a triangle here, we first would graph the triangle on the coordinate plane using the vertices given. So for example 3, I'm going to go ahead and plot my points. Here's point B. Point N is going to be 4 up 2. And then lastly, A is going to be over 1 up 7. So there's my triangle. So let's go ahead and connect those dots. Look at my triangle. And what we need to determine here is a couple things. So first, we're going to use the distance formula to classify the triangle by its size. Now, this takes a little bit of work, so we're going to go ahead and just write out our segments. We have segment BN, segment NA, and then what other combination do we not know? BA. And in order to get these three lengths, we're going to have to use the distance formula. So let me do the first one together with you, and then I'll have you pause to try the other two. So point B is negative 2, 4. Sorry, negative 2, negative 4. Point N is 4, negative 2. Just as a reminder, the distance formula is the following. Write that down here on the right-hand side. So when I set up my distance formula, we're going to take our 2x values, which are 4 and negative 2. So 4 minus negative 2 squared. And then we'll take my y values, negative 2 minus negative 4, quantity squared. And then we're just going to type that entire thing into our calculator. Make sure you type it in with the parentheses. And if you want to write minus negative, that's obviously okay. But obviously, we might know that when you subtract a negative, that's actually adding. And so that's an option that we have as well. I get an answer here of 2 root 10 in my calculator, which is a decimal approximation of about 6.3. So go ahead and pause this video, and I want you to try this with segment NA and segment BA, and let's see what we get as our distance formulas. Welcome back, and here are the other two distance formulas that I've set up. So I put the points underneath as reference points, use my distance formula over here off to the right-hand side to set the problems up, and then use my calculator to speed up the math so that we can get our answers. So with these numbers, there are two things we can do. So back in Unit 3, when we learned coordinate geometry, the first thing we learn how to do is to classify a triangle by its sides. So in this case, I look at my three lengths, 6.3, 9.5, and 11.4. I see three different sides. So three different side lengths. Actually, maybe that's what I write. Three different side lengths. And so our conclusion from that is that this triangle is a scalene triangle. That's our first conclusion, okay? But now our second part of this problem, and this is the part where we bring in the Pythagorean converse, is what if I want to classify this by its angles instead? Well, this is where we would use the Pythagorean converse. So I'm going to use the radical answers because those are my precise answers, and that's going to give me a more exact answer. Since 11.4, or the root 130, is along his side, my Pythagorean converse would look as follows. 2 root 10 squared plus 3 root 10 squared. I'll put that big question mark for the equality symbol or inequality symbol, and that's equal to the square root of 130 squared. So we're going to put this in our calculators, each one of these, and we're going to square them, making sure to put parentheses around it just like we are needing to here. I made a typo, so wait till I finish typing that in there. So the first one I got is 40. For the second one, and if you want to do this by hand, 3 squared is 9, root 10 squared is 10, so this is actually just going to be 90. Maybe that's quicker. You can also type it in your calculator, and then this is going to be 130. Okay, so once again, we're not sure what's happening here. 40 plus 90, when I add them together, is going to give me 130. And just like the first example we did, we actually end up getting these to be equal, which tells me that this is a right triangle. So my conclusion is that this is a right triangle. And if you actually looked at the graph, it actually looked like this could possibly have been a right angle, and now we have confirmation that that's exactly the triangle that we're working with here, for example. One more example that we're going to take a look at, and that is down below, triangle LAX. So let's go ahead and plot this. So we're going to go to 8 up 1, negative 6 up 1, and then lastly, over 1 down 4. Okay, so this was point L, this was point A, this was point X. We can connect these together. That's a really sloppy line. All right, there we go. So I get for doing live television right here. Okay, so just like we did before, we're going to still want to find those lengths. So we're going to find the length of LA, we're going to find the length of LX, and lastly, find the length of AX. Now, if you notice, point LA here, or sorry, segment LA is just a horizontal line. So I'm going to go ahead and save you the time. Don't do distance formula when it's a horizontal or a vertical line. So I'm seeing the length here as, let's see, 1, 2, 3, 4, 5, 6, and then another 8. So it looks like the length of LA is going to be 14. Once again, for the last time here, let's pause the video and have you set up the distance formula for segment LX and then segment AX. Let's see how you did. What I found out here is that segment LX and segment AX both actually ended up becoming the exact same value. So our first conclusion we need to make is to classify this triangle by its sides. Since two of the sides are equal, so I'm looking at the 14, looking at the 8.6 and the 8.6, this is going to tell me that this is going to be an isosceles triangle. So that's our first conclusion. And then to get our second conclusion, to figure out to classify this by its angles, we're going to go ahead and use the Pythagorean theorem converse. Since 14 is my longest side, we're going to use those radical numbers instead. This will be the square root of 74 squared plus the square root of 74 squared, because they're both the same. We'll do that question mark for our equality symbol. 14 squared, this is going to become 74 plus 74. 14 squared is 196. And when I add those together, we're going to get 148. And as we can see here, it looks like c squared is going to be larger in this situation. That conclusion is going to tell me that when c squared is large, that means that the angle is large, therefore it's an obtuse triangle. So this is going to be an obtuse triangle as our conclusion for classifying by angles. And again, by looking at the drawing, you probably had a pretty good idea, but this mathematics is going to give us the 100% without a doubt proof that we are looking at an obtuse triangle. So that'll conclude the extensions here in this video. As you can see down at the bottom, I have two examples which talked about extension number 1, and then, well, these were a lot of big problems. I only gave you one to do here of the second extension. So go ahead and try these problems out. Check in with me or check answer key once you are finished, and hope you find some success in the work here as we wrap up the converse of the Pythagorean theorem. Thank you as always for watching the video, and hope you have a good rest of your day.